Theresa Zittritsch.
So thank you all. I've done this presentation or a form of it before at Wake Robin a year ago. So I've polished it up a little bit, hopefully made it a little better based on my experience there. So what we're going to do is we're going to talk about constellations, one of my favorite things. I talk about this almost every month at our club. We have a section of the club meeting they dedicate to me, and I highlight some particular constellation and what you can see and what things are in the constellation. I talk a little bit about its mythology because a lot of the constellations that we see in our skies come from the Greeks, and there's a lot of mythology behind them. And so I do that on a monthly basis, and this is a little bit of an extension of that. And whenever I do something like this, I learn a whole lot because I like to dive into things and research them a bit. So we'll talk about the what, the who, the when, and the where on constellations. So the outline is we'll talk about the definition of what is a constellation, who defined these modern constellations, and sometimes we don't know, and in some cases we know exactly who defined them. And I'll go through some of the constellations by the seasons and why do we see different constellations. So as winter's coming, hopefully everybody knows what the Orion constellation is, but you see it every winter. You don't see it in the summer. We'll talk about why that is. And we'll talk about what we can see from our location on this big blue marble we call the Earth. And at 44.5 degrees or so latitude. And I'll talk a little bit about finding your way around the sky as well. And I passed around those cards, and those cards are they're a reproduction of something that was called Urania's mirror. And they were actually first produced in 1825, so those are old constellations before the more formal definitions today. Some of the constellations are deprecated, they're not in use anymore. The boundaries are vague, but the pictures are beautiful, and I actually use those cards, or a picture of those cards, every month at our meeting. And I also passed around a book, and the book has all the constellations, all 88 constellations, as well as some information on them. I know you can't read the book this quickly, but it's a great book. You can usually find that book in used bookstores. I think I found my copy for $1.50 from somewhere, so it's a good deal. So on to the presentation. So definitions of constellations. So what is a constellation? So like many of our words in Western language, it comes from Latin, and it can be translated as a set with stars. So it's basically a set of stars. And from the Oxford Dictionary, it's a group of stars forming a recognizable pattern that is traditionally named after its apparent form or identified with a mythological figure. But modern astronomers divide the sky into 88 constellations with defined boundaries. And they're not necessarily concerned with what we would call the asterism. So I'll talk more about that. So more on the definition. In the past, as well as for a majority of the present time, most people think of constellations as that collection of bright stars that form some figure. Some people think of the Big Dipper as a constellation. That's really an asterism, because the Dipper, there is no Dipper constellation. That's part of a constellation called Ursa Major, or the Great Bear. The area and primary stars of constellations were all a bit arbitrary. In fact, the pictures that you see in different books, older books, they can be quite different in terms of how they make up the stick figure of a constellation. And in fact, each culture, and I'm talking in this presentation, I'm going to primarily talk about the Western constellations because it's the ones that you'll all I think most people here will be familiar with. Ursa Major, Ursa Minor, the Big Dipper and the Little Dipper, the Orion constellation. Whereas in other cultures, we call that star lore for the most part. Most other cultures have their own star lore. So whether you're Arabic or different Native Americans, Navajo, Chinese, they all had their own constellations and things that they saw in the sky. Like when we look up at the sky and see clouds, everybody had their own thing, and they'd paint them on walls or document them down. And some are much older, like the Chinese constellations are very old, and they may predate some of the Western Greek constellations. But I'm going to primarily focus on the Western constellations. And I didn't know how big my screen was, so I apologize if the stuff is a little small. I don't know how much you can read from in the back. But this is a northern hemisphere shot of the constellations that we can see. So continuing on, in the present time, from a scientific perspective, most of what we thought are constellations are asterisms. So when you look up in the sky and you see like a northern cross, that's an asterism. If you see the Orion Nebula, that's not really the entire constellation. That's more or less an asterism. The Big Dipper is an asterism, not necessarily a constellation. Constellations are really formal boundaried areas that contain all the stars in that area. And I'll show a little bit about this later on, but they're defined scientifically, so there's no arbitrary stars. Stars in either Ursa Major or Ursa Minor. It's not on the boundary of those two. It's specifically defined to be in one constellation. And science uses that because they reference stars or objects in the sky by the that's one of the things they reference the location for these objects is by the constellation that they're in. It defines a specific area of the sky. And who defined the modern Western constellations? So one potential origin of what are known as the Greek constellations. So the Greek constellations are the original 48, 47 of which have survived to this day. Based on the location of those constellations and where those constellations aren't in the sky, it matches very well with the view of the sky for the ancient Mesopotamians. So this is circumstantial. We don't really know if that's where that was the original origin of the constellations, but we know that the Greeks didn't define them. We know that the Egyptians didn't define them. And they were on cave paintings, and they were defined long ago, well before this time. But as you'll hear in a bit, it was the person who documented them who gets a lot of the credit nowadays for defining those constellations. So the original constellations, who documented them was Claudius Ptolemy. He was an Egyptian from Alexandria. He was a scholar. He didn't invent the constellations, and he didn't even name them, but he took the time to document them. And they're called the Greek constellations because they're named after Greek mythological characters. And Ptolemy documented them in a treatise called the Almagest, which is also written in Greek. A little bit about Claudius Ptolemy. So he lived in 100 to 170 AD, an Alexandrian. He was an astronomer, he was a mathematician, and he was a geographer. This guy had a lot going on. So like I said, he authored the Almagest, and that's the oldest surviving treatise on astronomy. And this was the treatise that originally set off the geocentric definition of the universe. So basically the Earth was at the center of everything. The planets, the sun, everything revolved around the Earth. And that lasted, for a very long time, I think until Nicholas Copernicus came around in the 1500s. So it lasted 1,300 years. So that's a pretty long time for all of the people on the Earth and all the scientists to not figure out that we weren't really at the center of the universe. So it's pretty amazing. But this guy, so he did a lot of stuff. He mapped more than 1,000 stars and their movements. In this Amalgast, he also included the definition of the original 48 Greek constellations, 47 which are still used today. In fact, 48 of his constellation areas are used. One of those constellations by a successor was actually broken up because it was too big into multiple constellations. So in reality, really using all of his constellations, they just broke it up into separate pieces. So, and I'll talk a little bit about that. He leaned heavily on the works of Hipparchus, who was the father of trigonometry, and also defined the precession of the equinoxes. So, and you know, that's when the celestial equator lines up with the Earth's equator at noon, and I think this is on the exact equators. The sun is directly overhead, so you have a summer. What is it? June and December equinox when the days are exactly equal.
September, March.
Pardon me?
September and March.
Thank you. He wrote a treatise on the movement of the planets. I must be thinking of the solstices.
You got it.
Thank you. Okay. He wrote a treatise on the movement of the planets. So when also he had to, because the planets don't move exactly like the stars and the moon, they actually move backwards sometimes. And that's because the Earth is going faster in its orbit than the planets. So we catch up and we pass them, and in the sky it looks like they're going backwards sometimes, night to night, instead of moving forward like the stars night to night. So he wrote a treatise, and he used some trigonometry to prove his theories, which unfortunately were incorrect. And he documented the latitude and longitude of 8,000 locations, which is amazing back at that time. And he also authored and tried to make more relevant astrology, unfortunately, which isn't a science. And so Ptolemy's 47 constellations, and actually I think I've got 48 here. But the last one, Argo Navis, was deprecated, so it was split up into multiple constellations. But I'm sure you've heard of many of these. Ursa Major, inside of Ursa Major is the asterism, the Big Dipper. That's the Big Bear. Ursa Minor, inside of that is the asterism, the Little Dipper. That's the Little Bear. Era, you probably haven't heard of this one. It's not very visible. I don't think there's a lot of objects to look at in Era. The Altar. Boöte is a very prominent constellation in the summer, the herdsman, Hercules, a hero, and I'm not going to read all of these, but a lot of stories are made up from these different characters in Greek mythology. And I'll go through one of those a little bit later. And you can stop me anytime to correct me or whatever if you have a question. So these are the original 48 constellations. And also, I sent around those Urania's mirror. The 48 constellations should be entirely in those cards, in those 32 cards, plus some extras that have since been discarded or deprecated when they were finally formally defined. So here is just some of the, in fact, these are images from those cards. So you have Cassiopeia, Queen Cassiopeia, King Cepheus, you have Orion, you have the Lyre for the constellation Lyra, you have Taurus the Bull, Pisces, can you see my cursor? Not much. So you have Sagittarius there. In the bottom right corner, you have the Little Bear, Ursa Minor, and Draco, which wraps around the pole. Those are circumpolar constellations, so they can be seen all year long in the northern hemisphere. You have Cetus, the sea monster. This constellation here is called Ophiuchus and Serpens. So there's actually two constellations here. It's the only constellation of the bunch that actually is broken in two. So Serpens, like I said, no constellation, there's no arbitrariness to where stars are. They're either in one constellation or another. So Serpens is actually bisected by Ophiuchus, which is in the middle here. So Ophiuchus is the serpent bearer, and then the serpent here has two different pieces, but they don't come together. They're actually separate areas of the sky. You have the Gemini twins, and you have the daughter of Cassiopeia and Cepheus here in Andromeda. In Andromeda and Queen Cassiopeia and King Cepheus and Perseus have a story that I'll tell later from Greek mythology. So who defined, so that was 48 and 47 have survived of the initial constellations. There's 88 constellations today. Who defined the rest? And it took, again, another, 1,500 years before we filled up the rest of the sky. And these folks here, Nicholas Louis de La Salle, Petrus Plancius, along with two of his captains, Keyser and Houtman, and Johannes Hevelius and Caspar Vopel were rounded out those who defined the rest of the constellations. So we'll start with Petrus Plancius, and Keyser and Houtman. So Petrus was a Dutch explorer, a cartographer, an astronomer, and lived from 1552 to 1622. He's one of the Netherlands' most famous cartographers, and he was one of the founders of the West India Company, which probably many will recognize. Great explorers back then. Charted many of the trade routes, trained his captains to take star observations. In particular, Keyser and Houtman took a lot of star observations. And to fill in the current sparse astronomical maps that the Westerners had of the southern seas and the southern hemisphere. So with observational input from Keyser and Houtman, who are also credited with these constellations, he documented 12 new southern constellations, and mostly of things that they saw. So, back in the time of the Greeks, the Greeks and the Mesopotamians and those before them, they're about mythical figures, gods in the sky, if you will. And, in the times of enlightenment, they're starting to think, well, let's put some things in the sky that, these new wonderful inventions that we have, and as well as some of the new and interesting animals we're seeing. So that's what you'll see from Petrus and some of his successors. So the initial 12 constellations that Petrus defined were included in something called the Uranometria, which is probably one of the most famous star atlases ever defined, authored by Jonathan Bayer, who's also very famous in astronomical circles. And in 1612, Petrus also proposed an additional 8 constellations, 3 of which were formally adopted. So again, I apologize if you can't see this very well, but this includes many of the constellations that Petrus defined. Columba, the dove; Apis, the bird of paradise, something they saw on their voyages; Chameleon, again, I think something they saw on their voyages; Musca, a fly; Valaris, flying fish; Monoceros, a unicorn. Don't think they saw many of those, but maybe after a few tankards of ale, they saw some of those. Camelopardalus, a giraffe. They saw that. And a grouse, a crane, and pavo, a peacock, and Indians as well. So native they weren't Native Americans at the time, but natives in various lands, India in places, but Indians. And here's the list of the constellations with their names. Dorado, a dolphin fish, a triangle. This is Triangulum australis, so this is southern triangle. There's also a northern triangle that Ptolemy documented in his set of constellations. Hydrus, a sea serpent. I'm sure they saw many things in the water they couldn't understand. Toucans, a bird. So that was Petrus. And after Petrus, we have Nicholas Louis de La Salle. He was a member of the Royal Academy of Sciences. And he was under the patronage of Jacques Cassini. And I don't know if anybody recognizes the name Cassini when it comes to astronomy, but Giovanni Jacques' father is known for discovering Cassini's and naming Cassini's division in the rings of Saturn. So if you come to one of our outreach events, that's one of the things we love to show people. People are usually wowed by looking at Saturn through a telescope. He also discovered the 4 moons, 4 Saturn moons. And in a quest to understand the distance to the planets, de La Salle tried to use trigonometry. So he tried to get a baseline for a triangle, the longest area of baseline to make his observations from. And he went to a place called the Cape of Good Hope, which is near Cape Town in South Africa. So right on the coast. And at that place, he observed 10,000 stars in 11 months. That's a lot of observations to document. And he also, with all those observations, he defined 17 different constellations still recognized today, including 3 constellations which he split off. He took the Argo Navis, which was a huge part of the sky. So I don't know if people recognize the name Argo from Jason and the Argonauts. So it was one of the quests, mythological quests, and the Argo was the ship that the Argonauts were on. And Ptolemy had that constellation. I guess Nicholas thought that was too much area to take up for one constellation, so he broke it up into 3 smaller ones, which I'll show you in a second. And he also created the first ever constellation, in fact, the only constellation that's known for an actual geographical place on Earth. There's a tabletop mountain in the Cape of Good Hope where he made a lot of his observations from. That is now a formal constellation. So it's the only constellation, I believe, made up from a geographical place on Earth. And here's the list of de La Salle's constellations. So these are tools and inventions that were important in that time frame. One of them is just talking about angles, the octant of a circle, a chisel, a pendulum clock, an air pump, again, Mensa, the tabletop mountain, a pictor, painter, drafting compass, a mariner's compass, which is one of the 3 that came from the Argo Navis being broken up, sculptor, reticulum, which is a reticle for a telescope, microscopium, fornax, a furnace, puppus, the poop deck, that's another piece of the Argo Navis that was broken off, carina, the keel, another piece, that was the 3rd piece of the Argo Navis, telescopium, a very important tool, and vela, the sails of Argo Navis. And just to give you, so here's, these are depicted in some of those cards. Again, the telescope, a very odd-looking microscope. I'm sure that's what they looked like back in the 1500s, but that's a sextant, a furnace. This is the tabletop mountain, a pendulum clock, and part of the Argo Navis showing the, I believe that's Pyxis, the compass, the navigator's compass. Okay. So there were some remaining. That didn't make up all 88 recognized constellations. So that made up, if you've been keeping count, that was 79 of the 88. And who did the rest? So there was this person, Johannes Hevelius, from 1690. He wrote something called the Firmamentum Sobiescarium. So don't quote me on my pronunciations. But he defined a few more constellations. The hunting dogs, Canis Venatici, Lacerta, a lizard, a lynx, a cat, sextans, the sextant, Vulpecula, ox, Leo Minor, right next to Leo Major, the bigger lion, and Scutum, which is a shield. So he defined those 7. And then somebody came along, Caspar Vopel, from 1536, actually predates these other guys. He defined Coma Berenices, which is Berenice's hair. And this is a unique constellation as well, because this is the only constellation that's actually defined based on a real person. So this was Berenice's hair comes from a Queen Berenices from 246 BCE. And I guess she did she was sacrificing her hair, votive offering for the safe return of her husband, at that time King Ptolemy, no relation to the other Ptolemy, there were a lot of Ptolemies back then, King Ptolemy III, to come back from the Third Syrian War. So she basically cut off all of her hair and gave it as an offering for that safe return. And I believe he did come back from that war safely. So it was a good, I guess it was a good deal for her. And then Kieser and Houtman, besides being co-credited with all of Petrus's constellations, they also define this last one here that makes up the last of the 88. And that's the Crux, the Southern Cross. And if you're fans of Crosby, Stills and Nash, they talk about the Southern Cross and say one of their songs. So about sailing. So now that we've talked about all of, so that makes up all 88 constellations. But still back then, the constellations, they were still somewhat soft. Clearly, when you have very bright stars, like for instance, the stars in Ursa Major or the Dipper, that makes up a big part, they're pretty constant. People see those, and I have a picture here of Ursa Major, the constellation, and this is from one of those cards that I passed around, Urania's Mirror, from 1825, but you can see the boundary is basically this soft line. That would be very hard to define. I don't know, maybe you can't see it, but the constellation boundary is that soft line there. That would be very hard to define scientifically by coordinates. So for a very long time, for essentially thousands, 15, 16, 1800 years, we dealt with these soft definitions, but science wanted something better. So the constellations got some help from, in 1919, from something that was formed called the International Astronomical Union. So this was a formation of a group of scholars and astronomers who wanted to formalize the sky so that it would be easier to do science. And they held their first General Assembly in 1922. So from Petrus or even Ptolemy back in 170 or so AD up to 1922, that's a long time for things to exist, very soft and fuzzy, if you will. And in 1922, the astronomical or astronomer community basically said is enough. We need to formalize these things. We need to make them constant and be able to definitively say where a particular star is in a constellation. And with the help of Henry Norris Russell, and he's also famous for something called, if you're an astronomer, the Hertzsprung-Russell diagram. And he worked for Princeton, which was very big early in astronomy, along with Draper. And in 1925, in 1922 at the first General Assembly, they formalized those 88 constellations. So those cards I sent around, there are many constellations that didn't end up in the final 88, but they formalized those 88 constellations, and they stand today, those 88. And but we didn't yet have formal boundaries. We still had these soft boundaries. And at the second General Assembly of this organization, Eugene Delport of the Royal Observatory in Brussels presented a proposal to formalize the boundaries of the constellations. And they're using something called, and you'll see it in some of my charts, they're using these measurements called right ascension and declination. And what they do is they put all of the constellation lines along those lines of right ascension and declination, which make them very easy to definitively say where a star is in terms of which constellation it is, where an object is. They're no longer these fuzzy round lines. They're all linear, piecewise linear. They're complex objects for sure, but they're all linear lines that these boundaries are defined in. And so he made this proposal in 1825. They appointed Delport, along with a committee, of course, to work on the formal definitions with requirements that all of the variable brightness stars defined up until that time. So astronomical work was going on all this time, and people were, cataloging variable stars and different, Messier's objects and comets. And so they put this requirement on Delport. So you'll see some of the constellations have some funny shapes. It's because of these requirements that the IAU put upon Delport. And in 1928, Delport's committee updated the boundary recommendations, that were approved and still stand today. They were originally published in 1930 in the Delimitations Scientifique des Constellations. And they basically cover 100% of this, the celestial sphere that we can look at from anywhere on the globe. So, which is kind of cool. That was a big accomplishment. And here's what I meant by following lines of declination and right ascension. So right ascension you can think of as longitude, going around the celestial sphere. We measure them in 24 hours, makes a full circle, and we break up the hours into minutes and seconds. So when we talk about things in the sky, when I point my telescope at something, I pointed it in right ascension and declination. And so that's right ascension is more like longitude. Latitude is more like declination, and at the celestial equator, basically over the Earth's equator, projected out into the sky, that's zero declination, and you go up to 90 degrees to the pole, and down to minus 90 degrees to the southern pole. And so everything in the sky right now is then measured in right ascension and declination, and you can see here's Ursa Major, and here's the asterism for Ursa Major, but every star in this big box here, this big funky box, is part of Ursa Major's constellation. And I'm sure there was some variable star here discovered and assigned to this constellation when it had a fuzzy boundary at some point in time, but and Delport had to make sure that he included that star in Ursa Major, and ended up with some interesting shapes. You'll see all kinds of little knockouts and corners and crevices. But they're easily defined in terms of right ascension and declination. So declination is going this way. This way is pointing towards, in this case, pointing towards the North Pole. And right ascension kind of goes this way. And these lines may seem straight, but they're actually curved. So they're curved in circles around the sky. And that's how all the constellations are defined. And here's a list, and you probably can't read it. Here's all the northern constellations, I think. I want to say there's 32 northern constellations. We have bigger constellations in the north. And I think there's 56 in the southern hemisphere. A lot of small constellations, tiny constellations in the south. Things like the compass or Crux, they're fairly small constellations, fairly small areas, thus you get a lot more of them. So, any questions from any of that? So what were the constellations used for in the past and now? So in ancient times, when I say ancient, Mesopotamians, a lot of mythology, based on the original 48, the constellations, at least in part, were used in ways to honor and remember the stories of the various Greek heroes, the gods, the myths, the 12 labors of Hercules, and continuing to tell these stories. Orion the hunter, Perseus who slayed Medusa, and there's tons of these different stories. And that was a primary use back in ancient times. And in fact, one of the things I do monthly is I talk about some of these myths. And this is a little on the myth of Perseus. And it was named by Ptolemy. In mythology, Perseus is a Greek hero. And it's only one of 6 constellations, though, that make up the Perseus myth. And he was born a son of Zeus and a mortal woman. Zeus was prolific in that way. Many of the myths come from Zeus and his promiscuity with various mortal women. And so he was a son of, of the god of all gods and a mortal woman. And he was sent on an impossible quest to kill Medusa, one of the Gorgon sisters. I believe there were 3 Gorgon sisters. And he achieved this goal by using a shield given to him by Athena to avoid looking directly at Medusa, and was able to lop off her head as a result without looking at her. And as an aside, Pegasus sprung from the neck of Medusa after Perseus beheaded her. And in red are all the different constellations associated with the Perseus myth. And upon returning from his quest, Perseus came across a woman, Andromeda. If you remember in the cards there, the picture of Andromeda, she has chains. She's shackled, and she was chained to a rock. Perseus came across this woman, Andromeda, the princess, chained to a rock to be sacrificed to the sea monster Cetus. And why was she being sacrificed? Well, she, as I said earlier, was the daughter of King Cepheus and Queen Cassiopeia. And the queen angered Poseidon, another one of the major gods at the time, by boasting that their daughter, Andromeda, was more beautiful than the Nereids, which were part of Poseidon's world. And Poseidon sought revenge for this slight against his Nereids, and by sending floods into King Cepheus's kingdom and ravaging the land. And as many of these myths go, they went to I can't think of the name right now, but a seer, and the seer told them the only way to get out of this, what Poseidon was doing, was to chain their daughter and sacrifice their daughter to the sea monster Cetus. And that way, the floods will stop, all will be good again. And unfortunately for Andromeda, that's exactly what the king and queen did. They chained her to a rock to be sacrificed to Cetus. But luckily for Andromeda, our hero Perseus came along and turned the monster to stone with the head of Medusa. So that's one of the many myths. In fact, I just finished, if you're interested in Greek mythology, I just finished 2 books by a person named Stephen Fry, who's written 2 books on Greek mythology. Very interesting stuff. It's just just what people believed in and all these stories from ancient times. So continuing on in what constellations were used for, so clearly, putting aside ancient times, when you talk about the thousands to the 18th century maybe, navigation was a big thing, obviously. Helped early travelers find their way. They used the stars, guide them, Polaris, towards the north. They eventually started using sextants. Agriculture, my understanding is that the early constellations helped farmers decide when to plant and when to pick. So certain constellations would come up and they'd say at a certain time of the night, and they'd say, it's time for us to start picking our crops. Same thing in the spring with planting. As we entered into more in the Enlightenment ages, a lot of the constellations just became tributes to human ingenuity. Things like sextants, microscopes, telescopes, chemical furnace, the fornax, and the mariner's compass. And lastly, unfortunately still, 12 constellations right along this thing called the ecliptic. And we haven't talked about the ecliptic, but our Earth is, I wish I had a ball. Our Earth is tilted about 23 degrees from the rest of the plane of the planets and the sun. So we're kind of going around the sun on this tilt, and that's also how we get seasons. So, how we get solstices and equinoxes. We're tilted, and we're going around the sun here. But that tilt creates this line across the sky, imaginary line, or the path of the planets and the sun take. So if you notice, they're taking the same path across the sky. The sun during the day and the planets in the evening. So that's the ecliptic. And the constellations that are on the ecliptic are the constellations of the zodiac. So things like Aquarius or Sagittarius, Cancer, Leo. I think Taurus is one of them. In fact, I have them here. So, and you see this kind of rolling line as you see a lot of times with satellites. It's because of this tilt, the difference in the path of the satellite, or in this case, the sun and the planets are in a different plane than the tilt of our Earth. So these are the constellations of the zodiac. And a lot of times, because the planets ride that same ecliptic, you'll hear about, for instance, Jupiter is in, I believe it's in Taurus right now. So Jupiter is in Taurus. That's because it's in that constellation. It rides along the ecliptic, and I think Saturn right now is in Aquarius. So I was just looking at them last night. So the other thing, and of course one of the reasons the International Astronomical Union was formed was they want to do science. So scientists want to do science, and they're basically to reference a part of the sky. It's the first level of location to discuss any feature, whether it's a galaxy or a new discovery of a comet or an asteroid. You can define it by being in a particular part of the sky. You can say such and such is in, Ursa Major or Ursa Minor. As I mentioned a bit ago, to reference where the planets are at a particular time or a particular season. To reference the focus location that meteor showers emit from. So you probably heard of the Perseids or the Orionids or the Geminids. Those are all meteor showers, and the focus point if you track back where the meteors are coming from, you don't want to look at that point for the meteor shower, but that's where they emit from. So they could be anywhere in the sky, but if you look at the track, they'll all kind of go back to that focus point. So, and that focus point is in a particular constellation, which is why they get that name. And unfortunately, still today, some people still do astrology. So how am I doing in time? 15 minutes. What can we see from our location? So we're at 44.5 degrees northern latitude. So in the constellations, when I talked about the northern and southern constellations, northern meant from that, basically from a line, an imaginary line that slices out into the sky from the equator. Northern would be north of that, southern would be south of that. So unless we were on the pole, we don't just see the northern hemisphere, we see part of the southern sky as well. So since Polaris is at 44.5 degrees up in the sky, the celestial equator, and I'll show you a picture of this, is basically 90 degrees on the other side of towards the south. So the celestial equator is 44.5 degrees. Anything below that are southern constellations. So we can see southern constellations as well as northern constellations in our skies. Some of them, we can't see them all. We can see those that go down, as far as the horizon, which is another 45 or so degrees. So, so I talked. Any questions on this? And here's the equinoxes, again, when the sun is exactly over the equator at noontime and in line with the ecliptic. So the ecliptic is this line here, which is tilted 23.5 degrees from our equator. I know it's a lot, so sorry if... And then the solstices, of course. And the summer solstice is when Earth is tilted. So if sun is here, we're tilted towards the sun. And the winter solstice is when we're on the other side. So if we're here, we're tilted towards the sun. On this side, we're tilted, the axis of the Earth is tilted 23.5 degrees away from the sun. And that gives us our seasons. So constellations by season. So I mentioned earlier that, the same constellations are visible, year after year in approximately the same month. And certainly in a human lifespan, that will continue to be the case. They move basically a little less than 15 degrees an hour in the sky. So a constellation viewed one night will return to the exact same location in our sky 23 hours and 56 minutes the next day. So I want to say it's about 10 seconds an hour. I think that 15 degrees represents about 10 seconds an hour that the constellations are moving forward per hour. So this means at any time the constellations advance, so east to west, everything moves in the sky. The Earth is spinning counterclockwise. So the Earth is spinning like this, the Earth is spinning like this. So so if a constellation's in space, space doesn't change. Say the constellations are in the room, so the Earth is spinning counterclockwise. We're getting the constellations coming into us from the east, this side, and that's why they go to the west. But this adds up to, this 15 degrees an hour, or 4 minutes a day, adds up to about 2 hours in a month. That 4 minutes times 30 days is 120 minutes, or 2 hours. So they advance 2 hours. So a constellation that's, say, at 6 p.m. in the same time zone, the same daylight savings time or not. If a constellation is here on October 1st, it'll be 2 hours later in the sky. And remember, the sky is divided up into 24 hours, this right ascension time. it's going to be 2 hours later or 2 hours farther west in a month. So that's why the constellations move night to night. Not a lot day by day, but over a few days or a month, they move quite a bit. In 12 months, they basically end up right back where they started. So good old Orion, you know, your winter friend, it comes up at just about the same time every year. Over much longer time spans, and something that will be a problem for the constellation boundaries as well, the Earth precesses. So we talked about the Earth being on this tilt versus, you know, if the sun's here, the Earth's moving around. But the Earth, that 23.5 degrees isn't, everybody has spun a top. I know everybody in my age group has spun a top. But, you know, a top precesses at the top. Its axis wobbles around a little. It's a wobble. And because of that wobble, all those things in the sky are going to be perceived in a different location over time, but that wobble is very slow. So it actually takes, so that wobble actually is circular for that axis. It takes 26,000 years for it to go in one orbit of wobble, if you will. So over 26,000 years, our pole stars will change many times. Might come right back to where it was, with our pole star being very close to Polaris, but our pole stars will change. The constellations will all look, you know, a little different, but that's due to precession. So, and I think I was going to talk about continue to talk about constellations by season. So our autumn constellations, the ones that are up right now, and this is a little arbitrary. It's kind of looking at the constellations from the meridian. This is an imaginary line that runs north to south and east, because these are the constellations that will be rising and continuing to see throughout the night. Whereas the constellations west of the meridian, the north-south, they're heading down. So they're going to become invisible as the night goes on. So this list, so you can see more than just this list on any particular night. It just depends on the time. So it's a little arbitrary, but Aquarius, Andromeda. Aquarius, like I said, is where Saturn is right now. Andromeda is off of, comes off of Pegasus. Cassiopeia, Camelopardalis, Draco, Ursa Minor, and Cepheus are all what we call circumpolar constellations. They're going to be on every one of my lists for at least for the northern hemisphere. They won't be for the southern hemisphere. There are circumpolar constellations for the southern hemisphere, but we don't see it here, so I'm not going to show them right now. But you could figure that out by looking at a map. They're the ones you could see all the time. Cetus, the sea monster, Lacerda, the lizard, Pegasus, the flying horse, Perseus, the hero, Pisces, the fish, and Triangulum. Those are all constellations that are kind of rising after nightfall in the autumn. And this is looking from the south. And usually us astronomers are, we're seeing the biggest hunk of the sky for the longest amount of time looking in the south, because when you look to the north, everything's revolving around the pole. So it's taking a much, in my opinion, a faster track around the pole. So I observe most of the observatories we do and build are usually pointing south. That's the way we like to observe. And looking from the northern side, so you can see way down here at 40, about halfway up to the zenith is a red dot here, you'll see the asterism of the Little Dipper, or Ursa Minor. So these are the southern sky. And remember, when you look, in the northern direction, when you look in the north, the constellations are going in this, the sky is moving in this direction. I don't know if anybody can see my cursor, maybe a little bit. So they're kind of, when you're looking north, things on the below the North Star are heading up, and things west of the North Star are heading down. And winter constellations, in the winter, Auriga, the Charioteer, and again these circumpolar constellations. Eridanus, the river, Lynx, Gemini, the twins, Cancer, Taurus, Orion, one of my favorite constellations, Lepus, Canis Minor, or Major, which is the big dog, and Canis Minor, which is the little dog. So those are your winter constellations, and that's looking from the south. And again, looking from the north, and there's the pole, and there's the zenith. Same constellations. And spring constellations, you get to see, springtime a lot of times we call the galaxy season for observers, because in the spring is when the galaxies are in the sky. And we're looking at a part of the, we're looking out of our solar system into regions of other galaxies, where in the summer you're looking at the Milky Way, in the fall you're looking at the Milky Way, you're looking at an arm of our own galaxy. In the spring, we're looking out past, out past our own galaxy's boundaries, and we're seeing a lot of other galaxies, and we enjoy taking pictures and looking at them. And looking at them in our size telescopes, they're faint fuzzies, but we can take some pretty nice pictures of them, so they're pretty cool. So that's spring, the spring season. And Coma, the reason I brought this up is Corona or Coma Berenices is a wonderful place to look for galaxies. Many, many galaxies looking out in that direction in our own galaxy. Same as in Leo. And that's looking south, and then north, again the same galaxies. Same circumpolar galaxies. Boötes is a great galaxy. The Herdsman. And then summer, I show this one a little lighter because it gets dark so late. Summer is a tough time for astronomers because we don't get to see anything until 10 o'clock at night, maybe a little later here actually, and the worst time for us, the worst time is when the sun is up the longest. We want it to be dark and to be able to see the sky through a telescope and see the faint fuzzy things. And then it gets early, it gets bright out again very, very early. So I think they call it astronomical twilight. Happens, we get a very small amount of actual dark time for astronomy in the summer. So, but here are the constellations. Again, you have your circumpolar. You add to this some of the beautiful constellations. Cygnus, just an absolutely gorgeous place to many nebula and things to photograph in the Cygnus constellation. Let me see what else. Ophiuchus, many things to see in Ophiuchus. Ophiuchus has many things called globular clusters, a compact, gravitationally bound set of stars. It looks like a giant snowball when you look at it through a telescope. Very interesting things, some of my favorite objects. Scorpius has some beautiful areas as well around Antares, the bright orange star near the horizon that you can see in the summer. And looking from the north, again, the same constellation. So a lot of sky out there, a lot to see. How do you find anything looking at the sky? And so I've got a few pointers here, but there's a lot of different pointers that you can use for finding things. So, so something that you can still see, even though we're heading into autumn, although you wouldn't know it by the weather today, something called the summer triangle. It's an asterism, but if you look up, starting in June, and again, it's late because it doesn't get dark very early in June. Starting around 9:30, you can start to see some of the brightest stars. So some of the three of the brightest stars in the sky on a path to go across the zenith, starting in the east, will be this thing called the summer triangle. And it's made up of the star Vega, the star Deneb, and the star Altair. And the brightest star farthest south of the three is going to be Altair, which is part of Aquila, the eagle. That's this constellation down here. Deneb will be the star farthest north, and that's the tail of Cygnus, the swan. So, and Cygnus is, you can't see it very well in this photo, but I like to think of Cygnus as flying down the Milky Way. So when you're looking at Cygnus and looking at the head and tail of Cygnus, you're basically looking at the path of the Milky Way in the sky. So if you can't see it very well, that's a good indication that you found it. And then Vega, one of the brightest stars in the sky, and this will be the one farthest west, is part of the constellation Lyra. So with this, you easily find three constellations, but if you look towards the direction this triangle is pointing when it's going west, you immediately find Hercules, so that constellation. So, and right behind this triangle on the other side, you'll find this little thing that I like to think, to me it looks like a kite, Delphinus, but it's actually the dolphin. So I always notice it as a kite when I look up in the sky, the tiny little kite. But you can find many constellations this way. So that's the summer triangle. So that's a great asterism to know. Helps you find many constellations. And if you look at a star chart, once you've found that, you can say, Ophiuchus is just below Altair, a little farther west. Or, the head of Draco is just above Vega, and so on and so forth. So it's a great pointer. It's a great asterism because they're very bright stars, and I'm over time. The next one is the one coming up. So you can still see that summer triangle now at dark. They're going to be the brightest stars. In fact, just before dark, before astronomical darkness, you'll see them pretty high in the sky right now. They're just transiting over the meridian. What's coming, though, and I can see in the early wee hours in the morning when I'm still up taking pictures or looking through the telescope, is you see this thing called the winter hexagon. So I think everybody knows where Orion is, or knows the constellation Orion. Well, on its right foot is a star called Rigel. If you start there and you head, I believe you go northeast towards a bright red star, the next brightest star close to Rigel, heading up and east will be Aldebaran, which is part of Taurus the Bull. And then as you continue heading farther up in the sky, you're going to find the brightest star in Auriga, called Capella, a big bright yellow star, beautiful star. And then as you head down from Capella, you're going to find something called the Twins. So this is part of the Gemini constellation, Castor and Pollux, again, very bright stars. And we look at those as one. So that's another point of the winter hexagon. And you have to wait for these constellations to get a little higher. So when Orion's just on the horizon, you're not going to find Procyon or Sirius because they're still under the horizon. They need to rotate up. You have to wait a few hours or a couple of months for the same time. But eventually what you're going to see is you're going to see this whole asterism kind of go across from the east, curve east to west in the sky. And I would say probably December, you should see all of these stars above the horizon. And you should be able to see, it's touchy. All of these stars, which all represent constellations. So if you found Rigel, you know where the Orion constellation, Aldebaran, Taurus the Bull, Capella, Auriga, the charioteer, Castor and Pollux are the twins of Gemini. Canis Minor, that's the little dog, that's Procyon, nice bright star. And then the very bright star Sirius, which is the big dog, Canis Major. So you find all those constellations. So that's the winter hexagon. So the two big things of the year, the summer triangle and the winter hexagon. But then you also have all the time even though the entirety of Ursa Major isn't circumpolar because we can't see it, a little bit goes below our horizon when it's dipping on its southern path around the North Star, but you can always see all of the dipper, the asterism, so it makes a great pointer for different times of the year. So when the dipper's high in the sky and the handle is pointing down, the handle will point towards, you can see that, Arcturus, which is the brightest star in Boötes, which is the herdsman constellation. And so the way we like to say this is we arc to Arcturus on the handle, and then we spike to Spica, which is another very bright star in the sky. And Spica is a star in Virgo, one of the biggest constellations in the sky, and also a big area for galaxy hunters. So we find a lot of galaxies and do a lot of galaxy viewing in Virgo. In fact, if you look here, those little ovals are all galaxies. So, and on the right-hand side, so I think probably most people know on the same dipper, if you take the cup end of the dipper, or the plow end if you're from England, and going up from the cup, that points towards the Polaris, the North Star. But if you go down from the cup, and again, it has to be high in the sky. If it's on the horizon, you're not going to find what it's pointing to. But when it's up in the sky, those same pointer stars in the reverse direction point towards Leo, the lion. So anyway, a few pointers there. If you look online, or there are many different pointers. In fact, I've seen where they use the Big Dipper to point to 10 different constellations. So I haven't used it that way, but there are many different pointers that you can use. Here's just a few to get you started. And other means to navigate the sky, certainly smartphones. There's 100 apps probably for your smartphone. Unfortunately, smartphones, they're bright and they take away your dark vision, so once you look at your smartphone, then you can't see any more sky. So it makes it hard. There's this other thing, this old-fashioned thing called the planisphere. I wanted to bring one along, but I couldn't find mine because I'm always using my smartphone, I guess. But it's an oldie but a goodie. It doesn't take batteries, doesn't need to be charged, no subscriptions, and doesn't ruin your eyesight. So it's basically a tool that you have to buy it for your particular place on the globe, so it's only good for maybe 10 degrees of latitude. But you basically put your date and time on there, you spin two circles, and you hold it up, and you could match it up with the sky. So it's pretty cool. And I think I'm almost out of my extra time. And I use these information sources a lot. There's something called Constellation-guide.com online. Gives you pronunciations, tells you all the mythology and all this stuff. And that book I passed around is also a great reference. International Astronomical Union, space.com is a great resource. Earthsky.com, Wikipedia, of course. I use Stellarium and Sky Safari. There are a couple of software applications. They work great also. And that's it. So, thank you. Any questions?
Yeah. When do you think that the early astronomers realized that bright stars would not necessarily, well, all the stars were not in the same plane as you, or dome, or sphere?
Oh.
Would they ever recognize that?
When things were really far away?
Well, yes. I mean,
well, Hubble was one of those.
A bunch of stars, but there's no direct relationship between them. They're all, some are nearer, some are further.
Oh, I see.
So we see it as a big difference, but
yes. Yeah, they're not necessarily, and they're not actually.
There could be nowhere near each other.
Exactly. The one star could be a dim star, could be extremely bright but very far away. Yes, exactly. Yeah. So they're in line with us. So we see them as a dipper, But in space, they could be all, likely they are all in different distances.
And then would they realize that, like our star, our sun, we have planets running around it?
Yeah. Well,
That's a mind-blowing thing. When,
oh yeah. It took what, 1,200 years from Ptolemy. Everything's revolving around us to, we're revolving around the sun. But then all those other suns out there, basically they're suns. Our sun is a star, and the stars out there are all suns.
And
Yeah.
we're standing, right? And what we're standing into.
Yep. And all those stars have planets and planet systems likely of some sort. So, I guess I don't know all of that. I don't know when that first realization came. So maybe somebody in the audience does that, but I'm not sure. I'm just an engineer, so. Yeah.
What's the story about Sagittarius and Ophiuchus? I heard somebody tell me that they were modifying the zodiac, and if you were, a certain birthday, you might not be Sagittarius anymore. You might be Ophiuchus or something.
Ophiuchus, right? Ophiuchus.
I mean, do you have any comments or knowledge about? It sounded like
You're talking about
all the newspapers the next week.
Oh, you're talking astrology.
Yes.
Yeah, I'm not. I have to admit, I'm not brushed up on my astrology. So.
Nor am I, but I just thought it was kind of interesting.
No, I guess Ophiuchus is. If I think about Ophiuchus, it's probably on the ecliptic, or at least part of it's on the ecliptic. It's quite a large constellation. I have heard that people talk about that there have been 13 constellations on the ecliptic.
That's what it is, right?
Yeah. So, but I hadn't heard that the astrologers were adding one. So, but
Got it.
yeah, yeah.
A few years ago, I was able to visit Hawaii, and I
Ooh.
went on a tour on the mountain where all the observatories are.
Yeah.
And the person that was our guide on our tour was talking about the names of the constellations that the Hawaiians use. Like
Oh, how
the
cool.
new, different.
Oh, yeah.
Different shapes and different groupings.
Oh,
that was
yeah.
In their mythology, and so that was just kind of.
That's very neat. Yeah, I'm interested in that. So I want to, look at some of the more native. For this talk, I really wanted to know a little bit more about maybe what Abenaki culture or, local, but I haven't gotten around to that yet. But one of these days, through one of my talks, I'm gonna get some research done on Abenaki culture and star lore. So very cool. So I know Polynesians have a whole set of separate culture. In fact, Stellarium's a free program, and you can get a lot of the star lore from different cultures right from links in Stellarium. They have a link for star lore, and then there must be 100 different cultures that they have star lore links from. And I don't know how exhaustive or how complete they all are, but it's maybe a great starting place. So I'll have to look for Hawaiian, because they have great skies.
Any last questions?
Yeah.
Theresa Zittritsch, thank you very much.
Thank you.